In this video, we will look at trigonometric equations. Before we get into that, just a quick reminder again on how to do mathematics. So number and copy the examples. So ask your teacher if there are any steps that you do not understand. Then number the questions, and unless you have the ability to get fit while watching someone else run, you must do the questions on your own before watching the answers. Then mark your answers. If it is incorrect, write down the corrections and make sure you understand where you went wrong. This will enable you to do better the next time you attempt a similar sum. Alright, so just an overview of the video. We're going to do or look at the QRS method, and then we're going to do general solutions, and then specific solutions, and then some harder sums which involve quadratic and higher level sums. Now, to look at the QRS method, the first thing, the Q stands for quadrant. So the first thing you want to do is look at the quadrant. Then the second one is the reference angle, and the third step is to solve. Now, if we have, for example, cos x equals to minus 0,486. Now, to look at the quadrant, we want to know where is cos. Since we have a negative over here, we want to know where is cos negative. So if I have this quadrant, cos is negative in this quadrant, the second quadrant and the third quadrant. That's where cos is negative. So in other words, the quadrants are the second quadrant and the third quadrant. Next up, we need to work out the reference angle. So what the reference angle is simply the value of x, and we use our calculators to do that, because we say what is x? X is equal to the inverse of cos, and we're not going to include the sine because we've accounted for the sine in the first step. The inverse of 0,486. So that we just put onto the calculator. We say shift cos 0.486, and this will equal to 60,92. So 60,92 degrees. Alright, so now we have the quadrants and we have our reference angle. Now we simply need to solve. So since we know it's negative in the second quadrant, for the second quadrant we have 180 minus our reference angle. So here we have that x is equal to 180 minus the reference angle of 60,92 degrees, and then we just add, cos has a period of 360, so then we add the period of 360 degrees times by k, or x is equal to, so this was for the second quadrant. Now for the third quadrant is 180 plus the reference angle. So this is going to be 180 plus the 60,92 degrees, and then we just add the 360 k degrees times by k to include the period where it will have the same solution every 360 degrees. So just to simplify that, we have 180 minus, so 180 minus the 60.92 is then equal to 119,08. So 119,08 plus 360k, and here we have x is equal to 180 plus, so this will give us 240,92 plus the 360k. Alright, that was the QRS method. We now go on to general solution. Now for example 11, to find the general solution, the first thing we're going to do before we use QRS or go into QRS, the first thing we need to do is to isolate our ratio. So that means this tan and whatever the angle is, we need to isolate this or write this in terms of tan theta minus 10 degrees. So the way we're going to do that, that's just following the normal equation rules, where first we need to get rid of this 1,077, taking it to the other side, it becomes a negative. So I have 3 over 2 tan theta minus 10 degrees is equal to negative 1,077. Then to get rid of this 3 over 2, I can multiply both sides by 2 over 3. Since we only have one term here, we just multiply both sides by 2 over 3. What will happen on this side, it will cancel, and then I can just simplify that on my calculator. So tan theta minus 10 degrees is equal to we say negative 1,077 times by 3 over 2, or 2 over 3, and that gives me negative 359 over 500. So negative 359 over 500. Alright, so now to start off with QRS, first we need the quadrant. So we can see that this value over here is negative. So if I look at the cast diagram, then where is tan negative? Tan is negative in the second quadrant and in the fourth quadrant. And so I write down second and fourth. Alright, then for the reference angle, my reference angle is simply this theta minus 10 degrees, that value. So theta minus 10 degrees will be equal to the inverse of tan of 359 over 500, and I don't use the sign because I've incorporated the sign in the quadrants. So this value is then going to be, so I say shift tan and then 359 over 500. So this gives me 35,68. 35,68. Okay, so that's our reference angle then. And now to solve. Now we use our quadrants and our reference angles to find the general solution. And this, if it's the first quadrant, it's just your reference angle. If it's the second, it's 180 minus your reference. If it's the third, it's 180 plus your reference angle. And if it's the fourth, it's 360 minus your reference angle. So we have the second quadrant. So we're going to say theta minus 10 degrees is equal to 180 minus the reference angle. So this is 180 minus 35,68, and then we add the 180k because tan's period is 180. So for sine and for cos theta, your periods are both 360 degrees or 360k, but for tan it's always 180 that you add. Okay, so now we simply need to solve for theta here. I'm going to take the 10 over to the other side. So theta is equal to 180 degrees minus 35,68 plus 10 degrees plus 180. Okay, now notice that the 10 that I take over only influences my angles, my degrees, not the period, because we have to add like terms, and you can't add the degrees to a value that contains k, or variable k. So we're simply going to say 180 minus 35.68 plus 10, and that gives us 154,32. So 154,32 and degrees and plus 180 degrees k. Right, then or the other solution, theta minus 10 degrees will then be equal to, so for the fourth quadrant we use 360 minus our reference angle, so 360 minus 35,68 plus 180k. And once again we just need to solve for theta, so that's 360 degrees minus 35,68 plus 10 degrees plus 180k, and that gives us 360 minus 35.68 plus 10 is equal to 334,32. So 334,32 plus 180k. Right, now when it comes to tan, because the period is 180k, always just make sure that these two general solutions that we found here isn't the same, because what happens here is we've got a solution, let's say over we were in second quadrant, so over here this one is the 154 angle, and then the other one is probably in the same general solution, where this one, the other one we found was 334. So let's just make sure that this general solution doesn't always also include this general solution. So if I replace my k with 1, because that k is a variable that can be replaced with 1, 2, 0, minus 1, minus 2. So let's say if I replace it with 1, what happens? So if I have 154.32 plus the 180k, whereas I'm going to make my k's value 1, then I get 334,32. So you see that that's actually the solution as well. So this general solution actually includes all of this. This is the same general solution. So at the end of the day, I only need to, I don't actually need this part over here. So I can say, therefore, my general solution is simply going to be 154,32 plus 180k. That would give me all my possible values. So this actually only applies with tan because it's got 180k, whereas cos both would be valid, but always just test it to make sure. Question 11.1. Now this one we can already start and go ahead and do QRS, because we've already got this our ratio isolated. Remember, what is inside the brackets is part of the ratio, so you have to first do the QRS, and then we can isolate x. So to start off, we've got Q, the quadrant, and sine. This one is positive, this value. So where is sine positive? If I look at my cast diagram, sine is positive in the first and the second quadrant. So that's first and second. Then my reference angle, if I take the inverse of sine of this, my reference angle is going to be, we can actually write that down. You can say 2x plus 15 is equal to the inverse of sine of 0,38. So to calculate that, we have shift sine 0.38, and that is equal to 22,33. So 22,33. So that's my reference angle. Then finally, to solve, because we're doing general solutions, let's start with the first quadrant. So the first quadrant is simply just equal to my reference angle. So this is going to be 2x plus 15 is equal to 22,33 degrees. And then to solve for x, we have x is equal to, now first of all we're going to take the 15 over to the other side. Then we have 2x equals to 22,33 minus 15. So if we subtract 15 there, then we get 7,33. So it's equal to 7,33. And then if we divide both sides by 2, we get that x. And also remember that we had to add our 360k, because this is sine. So plus 360k. And if I divide, then I have to divide everything with 2. So if I add this variable, then I can only add it to its like term, which is a degree. But if I divide I can also divide the term that contains the k. So x therefore is then equal to, if I take 7,33 and divide it by 2, I've got 3,67. This is 3,67 plus 180k. And then for the second quadrant, which is 180 minus the reference angle, this will be, so I just say, okay, 2x plus 15 is equal to the 180 degrees minus my reference angle, which is 22,33, plus my period, so that's 360k. Right, now we just need to solve x from here. So the first thing I'm going to do is to take the 15 over. I've got 2x is equal to 180 degrees minus 22,33 minus 15 degrees plus 360k. Simplify this. I have 180 minus 22.33 minus 15 gives me 142,67. So 142,67 plus 360k. And then to get x on its own, I simply divide everything with 2. So x is equal to 142,6, so that's divided by 2. And this gives us 71,34. 71,34 plus 180k. So these are my two general solutions. We've got this one over here and this one over there. So for question 11.2, the only thing I have to do before I can get started with QRS is to isolate my ratio, and in order to do that, I'm going to divide both sides by 3. So cos x plus 20 degrees is equal to this 0,96 divided by 3, 0.96 divided by 3, and this gives us 0,32. Alright, so QRS quadrant, we see that this is a positive value, and cos is positive in the first quadrant and the fourth quadrant. So we have first quadrant and fourth quadrant. Right, then the reference angle, if I take the inverse, so my reference angle, which is x plus 20 degrees, that would be the inverse of cos of 0,32, and that would give us, so shift cos 0.32, and that gives us 71,34 degrees. And then finally, to solve, I have for the first quadrant, it's just equal to the reference angle, so x plus 20 degrees is equal to my reference angle, and don't forget to add the 360k. Then isolating x or solving for x, we just simply take the 20 over to the other side, so x is equal to 71,34 degrees minus 20 degrees plus 360k, and that 20 only applies to this angle. Those are like terms, so x is equal to 51,34 plus 360k. It's my first general solution. Or x plus 20 is equal to, now in the fourth quadrant, it's 360 minus your reference angle. So 360 degrees minus my reference angle, which is 71,34 degrees, plus the 360k. And then solving for x, we just take the 20 over. X is equal to 360 degrees minus 71,34 degrees minus 20 plus the 360k. And then we just simplify. So x is equal to 360 minus 71 0.34 minus 20. And that's equal to 268,66. So 268,66 degrees plus 360. Okay, so here is our general solutions. That was general solutions. We will now move on to specific solutions. Now for example 12, calculate theta in the following equation for 270 degrees is less than theta and theta is less than 360 degrees. Now first of all, we can see that this is tan theta over 2 equals to negative 1 over square root of 3 tan 40. Now the first thing, this tan 40 tends to confuse a person, but it's actually just a number. So the theta, or the ratio that we're going to solve for, is this one over here. Now if I take this expression and I put it in the calculator, that would give me, so I've got negative 1 over square root of 3 and then tan of 40. Then I've got this negative 0.48445. So this is just a negative number. Alright, so if I'm going to then solve for it, this is going to work exactly the same as the general solution, except we're just going to find the actual values between the given restrictions. So we're going to follow the same procedures. We're going to have since this is a negative number, I'm going to say that tan for quadrant, so for Q quadrant, tan is negative. If I have my cast diagram, then tan is negative in the second quadrant and in the fourth quadrant. So that would be second and fourth. Alright, and then the reference angle. So the reference angle will then be the inverse of tan. So that would be theta over 2, which would be tan, the inverse of tan, of 1 over 3 tan 40 degrees. And that is equal to, so if I say shift tan, then 1 over square root of 3 tan of 40, and close that. Then the reference angle will be 25,85, so 25,85 degrees. Alright, then finally, if we want to solve for it, then theta, for the first one, we've got the second quadrant. So in the second quadrant, we know that's 180 minus the reference angle. Third quadrant is 360 minus the reference angle. So for the second quadrant, we've got 180 minus 25. Oh, actually, sorry. We start off with theta over 2 is equal to 180 degrees minus 25,85 plus 180k. Since it is tan, we have the period as 180. So now, to simplify this, we can just say theta over 2 is equal to 180 minus this. So if I say 180 minus 25.85, I get 154.15, 154.15 plus 180k, and then theta is equal to, multiply through with 2, so we say that multiply by 2, and that gives us 308,30. So 308,30 degrees plus 360. Okay. Then for the other solution, we have we have in the third quadrant, we've got theta over 2. So theta over 2 is equal to 360 degrees minus the reference angle 25,85 degrees plus 180k. And then to simplify, theta over 2 is equal to 360 minus 25.85. That gives us 334,15 plus 180k. And then multiply through with 2. This one times by 2 gives us 668,3. 668,30 or 3 degrees plus 360. Okay, all right. Now, since we have the general solutions, we can now substitute in values for k that would give us the values that lie between these two restrictions. So first of all, let's start with this one. We have the 308.3 plus the 360, and then I'm going to start. Now, the first thing about this is if I put in 0, then my first solution will be this 308,3. That lies between these values, so I can say that theta is equal to, the first one is the 308,30. So let's see if we can find another solution. If I now substitute in 1, it's obviously not going to work. If I put in 1, then I have this solution. And then obviously anything else or higher would not work. And also minus 1, if I go down a bit, that gives me negative 51,7. All right, so that's all for that general solution. Next, we can try this 668.3, and we've actually seen now, if I put in a negative 1, this actually resembles, these two general solutions actually resemble the same thing. If I put in negative 1, then I also get this 308,30. So this is then the only solution that falls in this restriction. So theta is then only equal to 308,30 degrees. For question 12.1, find two values of x in the interval 0 degree to up to 180 degrees included, satisfying the following equation. So here we have cos 2x equals to 0.4. Now the first thing I'm going to do is to determine the quadrant. So quadrants, since cos is positive, and if I look at my cos diagram, cos is positive in the first quadrant and in the fourth quadrant. So that's first and fourth. Then for my reference angle is the 2x. So 2x is equal to the inverse of cos of 0.4. So that would equal to shift cos 0.4, and that's 66,42. So 66,42 degrees. Then for to solve, first of all, let's start with the first quadrant. Now, since it's the first quadrant, it's simply my reference angle. So 2x is equal to 66,42 degrees plus 360 k, since we are working with cos. And then to solve for this, I can just simply divide everything with 2. So x then is equal to, this is 33,21 plus 180k. And then that's my general solution for the first quadrant. And then in the what do you call it, in the fourth quadrant, 2x will be equal to, now fourth quadrant is 360 minus my reference angle, which is 66,42, and then add my period of 360k. So now let's just simplify this side first. So we have 2x is equal to 360 minus 66,42, and that gives me 293,58. 293,58 and plus 360k. Then we divide everything with 2 to get rid of the 2 in front of the x, or to isolate the x. So this is then divided by 2, which gives me 146,79. 146,79 plus 180k. Now I've got my two general solutions, so now let's substitute in different values for k to see if we can find solutions that fall in this restriction. Now I immediately have this one. If I have 33,21 plus 180, and if I put in 0, this will give me my first solution of 33,21. Then if I put in 1 and see, then it immediately falls outside of the range, so it has to go from between 0 and 180. So 1, and then if I try minus 1, it also falls outside of this restriction. So the only one was when when k was 0. So x is equal to, the first solution would be 33,21. Then I know there's 2 because the question says there's 2. If I look at my other general solution, I've got 146,79 plus, now 180 is plus 180, so I can put in 0 for k, and once again I would have this as my solution. It would be 146,79, and that also falls in the restriction. If I put in negative 1 here, it's going to be below 0 degrees. If I put in a plus 1, it's going to be over 180. So this is my other solution, 146,79. So 146,79 degrees. Then question 12.2. Right, so here's our equation over here that we need to solve, and here's our restriction. It needs to be between 0 and 360. Now first of all, before I can start with the QRS, I want to isolate my ratio. That means this. So just to do that, I'm just going to divide both sides by 2. So tan x plus 10 degrees is equal to this 3,464 divided by 2, and that gives me let's write it 1,732. So 1,732. All right, now to start off with, we have quadrants. So where is tan positive? Tan is positive in the first quadrant and in the third quadrant. So that's first and third. Then my reference angle will be x plus 10 degrees is equal to the inverse of tan of 1,732, and that is equal to shift tan 1.732. So this is 0,03, right, which doesn't look right. Oh, this has to be shift tan. That's not shift tan. So shift tan 1.07. 0.732. So 59,99. So I can actually go with 60 degrees. So 60 degrees my reference angle. And then finally I need to solve. So in the first quadrant I can just say 60 degrees plus 180. Okay. Sorry, I have to say x plus 10 degrees is equal to 60 degrees plus 180k, and solve for x. So x is equal to 60 degrees minus 10 degrees plus 180k. So x is equal to 50 degrees plus 180k. Right, and then x plus 10 is equal to, now the second solution or general solution will be in the third quadrant, which is 180 plus, so 180 degrees plus the reference angle 60 degrees plus my period 180k. To solve for x, I take the 10 over, it's 180 plus 60 minus 10 degrees plus 180k. So to simplify for x, we've got x is equal to 180 plus 60 gives us 240 minus 10 gives us 230 degrees plus 180k. Alright, now we need to find the specific solution. So x is equal to, so we're going to use our two general solutions, and x is equal to, and first of all, if I put this in the calculator, I've got, for the first one, I've got 50 plus 180k, and for k being negative 1, I can see this is negative 130, so this falls outside of my restriction over here. If I put k as 0, I get 50. That's inside my restriction, so this one is 50 is one of my specific solutions. Then if I make k equal to 1, I get 230, and 230 also falls inside my region, so this is then 230. So since this one also contains 230 plus the 180k, these are actually the same general solution, so we actually only need this part of it, and that would then be our two solutions. So that was the specific solutions. Now let's look at some problem solving questions where we have some higher level questions. So now for example 13, find the general solution of the following equation. Now in this case, we can see that we have cos squared x and a sine squared x, and then another cos x. So this can throw us off a bit because in this example we have different functions. And the first thing we want to try and do, if we have different functions, try and use your identities to substitute in. Like for example, if I know my identity sine squared x plus cos squared x equals to 1, and I want to replace or write sine squared x in terms of cos squared x, I can say sine squared x is equal to 1 minus cos squared x, and then at least I would have all of them, all of my ratios will be the same. So I'm going to replace this sine squared x, got cos squared x minus terms of, and then in place of sine squared x, I write 1 minus cos squared x plus cos x equal to 0. Alright, and then to simplify, let's just start by multiplying out that minus. Got cos squared x minus 1 plus cos squared x plus cos x equals 0. Alright, so here are two like terms. We can add this cos squared x. This gives us 2 cos squared x. And then I'm going to rearrange this. I'm going to write this cos x and then minus 1. And the reason I do that is if I look closely at this, this resembles a trinomial, where let's say if I replace cos x with a, just to see it clearly, or to see it more clearly, if I replace cos x with a, I've got 2a squared plus a minus 1. And I can do trinomial factorization on this. So I can say the factors of 2 is 2 and 1. Factors of 1 is 1 and 1. And I want to get plus 1. So make sure you can do this factorization pretty well. And then 2 times 1 is 2 and 1 times 1 is 1. To get plus 1, I say plus 2 minus 1. So the minus goes over here and the plus goes over there. Then my factors would be, if I put an a over there and there, this in factored form would be 2a minus 1 and a plus 1. And if I should write, so if I should apply that exact same factorization to my equation over here, it would simply be 2 cos x minus 1 and cos x plus 1 equal to 0. So now to solve for this, we know we equal both of these brackets equal to 0. So 2 cos x minus 1 equal to 0, or cos x plus 1 equal to 0. Let's start with this side. To isolate cos x, I've got cos x equal to a half, because I just take the 1 over and they divide by both sides by 2. And now I can start with my QRS method. So Q, quadrants, if I have the cos diagram, so if I have that cos x is equal to half, this is positive, and cos is positive in the first and the fourth quadrant. So that's first and fourth. And then my reference angle will be the inverse of cos of a half. So that would be shift cos 0.5. So this is equal to 60 degrees. And then finally to solve. Now for the first quadrant, I just have that x is equal to the reference angle 60 plus the period, which is 360 degrees. So that's my first general solution. And then or where x is equal to, now in the fourth quadrant, I've got 360 minus. So that's 360 degrees minus 60 plus 360 for my period. To simplify, I've got x is equal to 300 degrees plus 360k. All right. Then on the other side, if I solve for cos x, I've got cos x is equal to minus 1. Now, in this case, I don't have to go through all the QRS steps. This one I can actually read off from the cos graph. If I have the cos graph that looks like this, and over here we've got 360, and over here we have 180, then minus 1 lies over here and 1 over here. So every 360 degrees it would get to minus 1 again. So my initial value, or my initial value for x is equal to 180 degrees, but then every 360 degrees it's once again minus 1, so plus 360k. Alright, so all of these should then give me different solutions. If I have 60 degrees plus 360, this one would be different. If I say minus 1 over here, I'd get negative 300. Yes, so these two are different general solutions. So we have these 3 general solutions for our original equation. So once again, here we have now question 13.1, and this is also one that has different functions. So what can we do here? What we can do is we can actually change this ton into sine 2x over cos 2x. So let's do that. We've got 2 sine 2x plus sine 2x over cos 2x equal to 0. And once again, now I'm going to just factorize. I can factor out sine 2x. So if I take out sine 2x, and what remains is 2 plus 1 over cos 2x. All right. Then to solve for this, I can equal this to 0. So sine 2x is equal to 0, or 2 plus 1 over cos 2x is equal to 0. So now here I've got two different or separate equations, and both only have one function. Alright, so now let's start with sine 2x equals to 0. So if I look at my sine graph, it's 0 at 0, then once again it's 0 at 180, then it's 0 at 360. So to solve for the reference angle, we've got 2x is equal to 0 degrees, because it's 0 at 0 degrees, and then every 180 plus 180k, that's the period. So in actual fact, it's just 2x is equal to 180k. But if we have 2x, then it would, then to solve for x, I'm just going to divide both sides by 2. Then x is equal to 90k. All right. Then for the other solution, first of all, let's get 2 or cos 2x, the subject of the formula. I'm going to take over the 2 to the other side. I've got 1 over cos 2x equals to minus 2. And then just to get cos 2x on the top, I'm going to take the inverse of both of these. So this will then give me cos 2x equal to negative 1 over 2. Alright, now to solve for that, let's start with quadrant. This is negative, so cos is negative in the second and third quadrants. So second and third. Then the reference angle, so the inverse of cos is the inverse of cos, shift cos of a half, 0.5, is, no, that was not the inverse, shift cos 0.5, that's 60 degrees. My reference angle is 60 degrees. And then we solve. So the first general solution happens in the second quadrant, and that's where it's 180 minus. So 2x is equal to 180 minus the reference angle plus our 360 degrees, 360k. And simplifying this, we've got 2x is equal to 120 degrees plus 360k, and then dividing everything with 2, we have x is equal to 60 degrees plus 180k. Alright, then the other solution, or in the third quadrant, we've got 182x is equal to 180 plus our reference angle plus the 360k, and then 2x is equal to, this gives us 240 degrees plus 360k. So divide everything with 2, x is equal to 120 degrees plus 180k. Right, so here are our general solutions. This one, and this one. Now for example 14, in this case, I've got a 4 sine squared x on both sides, and here's an example of where you have to use factorization. Now the first thing I'm going to do is to get both on the same side. So you have 4 sine squared x minus sine x equal to 0, and then all I'm going to do is to factor out a sine x, and then what's left is 4 sine x minus 1 equal to 0, and then I can say either sine x is equal to 0 or 4 sine x is equal to minus 1 is equal to 0. Now we can solve for these two independently. Once again, I look at my sine graph, and sine is 0 at 0, at 180, at 360. So x is just going to be equal to 0 degrees plus 180k, or I can just simplify it by saying x is equal to 180k. All right, then on this side, to isolate sine x, I've got sine x is equal to 1 over 4. Now quadrant, where is sine positive? If I look at my cast diagram, sine is positive in the first and the second quadrant. First and second. Right, and then the reference angle is the inverse of sine of 1 over 4. So this is going to be shift sine 1 over 4. And that's equal to 14,48. 14,48, that's my reference angle. Now to solve. So first of all, we've got the first quadrant, so that's just my reference angle of 14,48 plus 360k. And I forgot to say x equals to, so this is right here, x equals to, and then, so this is my general solution there, and or the other one is x equals to, for the second quadrant, that's 180 minus my reference angle, 180 minus 14,48 degrees plus the 360k, and this is then equal to 180 minus 14.48. So this gives me 165,52. 165,52 degrees plus 360. Okay. So these are my general solutions. Alright, so here's one that also contains factorization. Now in this case I've got actually 4 terms, and what do I do normally with 4 terms? I do grouping. Now if I look at my first 2 terms, I can take out a sine x from both of them, which I'm going to do. I'm going to say sine x comes out. What is left from this term, if I take this out, 2 cos x is left, and here minus 1. And on the second one, it looks like I should take out a negative, because then I'll be left with the same expression over here. So 2 cos x minus 1 equal to 0. And then I can take this 2 cos x minus 1 out, which then leaves me with the sine x minus 1 equals to 0. So I can say that 2 cos x minus 1 equals to 0, or sine x minus 1 equals to 0. And then I can solve for cos x. So let's start with this one. Cos x is equal to a half. So once again, Q or S quadrants, it's positive in the first and the fourth quadrant. So first and fourth. Then the reference angle will be shift cos of 0.5, which we saw is 60 degrees. And then to solve for the first quadrant, we just have that x is equal to 60 degrees plus the 360k, or x is equal to, for the fourth quadrant, 360 degrees minus my reference angle plus 360k. So to simplify, x is equal to 300 plus 360k. Right, moving on to the other one, we just have here, we've got sine x is equal to 1. So once again, I'm just going to use my graph, and I'm going to look at the sine graph, which looks like this. Over here I see 1. This is where 360 lies, this is where 180 lies, and this is where 90 lies. So I can see that my x is equal to 1 at 90 degrees, and then I see that it's 1 again every 360 degrees. So I put in my 360k, my period. So here we go. This is then my general solutions for this problem. Then question 14.2. In this question, we need to use reduction formula. So taking this, I'm just going to simplify it by using so sine 180 minus x. So we know it's going to be sine in 180 minus, if I look at my cast diagram, then 180 minus is in sine's quadrant, so this is going to be positive. So this simply changes to sine x minus, now this 90 plus x is in sine's quadrant, so this is going to be a negative. So I can put a negative over there. Then because this 90, it's going to change to sine. So I can say that's negative sine x. All right, and that's it. So that's equal to 1. Now to simplify this side, this minus and minus multiplied together becomes a plus. So I've got sine x plus sine x equal to 1. Then this becomes 2 sine x equal to 1, and divide both sides by 2, so sine x is equal to 1 over 2. Alright, now solving for that's quite simple. The quadrants for sine being positive is the first and the second quadrant, and then the reference angle is going to be the shift sine of 0.5, and that gives us 30 degrees as our reference angle. Then to solve for our first quadrant, x is just my reference angle plus 360k, and or x for the second quadrant is 180 degrees minus my reference angle plus 360k. Alright, so to simplify that, we just have 150 degrees plus 360k. So here we have our two general solutions, this one and this one. Alright, so that was the last of the 4 sections. That means we're done with this video.